Today we will look at the concept of angles. So, what is angle? So, angle is formed between the two line segment. Let's say we have a vertex A and line segment AB, and there is another line segment AC. So, A is the common vertex of line segment AC and AB. So, angle subtended by this particular between the line segment is called angle A, and we measure these angles in degrees. So degree is a unit in which we measure these angles. So how do we define degrees? So let's say the angle between a full circle is 360 degree. So basically we start from 0. This line segment will start from here. Let's say there is a line segment AB and there is another line segment starting from A, and C point is coinciding with B. So these two line segments are overlapping each other. So angle between them is 0 degree because they are totally coinciding with each other. Let's say we try to take this point little up, like we try to extend this angle, the line segment C, up. So let's say this point is lying here, C. So now the line segment AC and AB has some angle, and this angle is, let's say, call it as X. So line segment AC and BC, they are extending the angle X degree. So the entire turn which this line segment will make is called 360 degrees. So from 0 to entire turn this line segment will make, that entire turn will extend 360 degrees. So let's say if we just take the half turn, so there is line segment AB and C has moved till exact opposite side of AB, and if we extend the line AB to the left side, this is like same line. Let me redraw it with a straight line. So this is point A, point B. So this is the same straight line, but C is lying to the left of A, like it has taken full round and it has reached here. So it is like half of the angle extended by A. So full circle makes 360 degree. Let's say this full circle will make 360 degree. So half rotation will make 180 degrees. So this is very important actually. Like the intuition to understand that a straight line always subtends 180 degrees angle. There are many different terminologies associated between this angle. So let's say I draw a straight line and there is a line segment A B which is marking, like, let's say line segment CD. So angle between this BAD and BAC, let's say we call it X and Y. So we can say these are like adjacent angles because it has a common line segment and a common vertex. So these two angles are called adjacent angles, and X plus Y will be 180 degree. Like this is very important because the straight line extends 180 degree. So x plus y will be 180 degree here. Cool. So like there can be problems like this, like given a straight line and a line segment like this. If they have given like x is equal to 30 degrees, then they will ask you y, like find the value of y. So we know like x plus y is 180 degrees. So y is equal to 180 minus degrees. This will be 150. So again, like it depends on how we want to make. Let's say a line segment starts from AB. C is initially like coincides with B, or C lies on the line segment AB. So the angle it makes with AB is 0. So it takes full one turn and reaches here. So it will take 360 degree. And again, if continues the motion and like goes in anti-clockwise direction and takes, let's say, one full rotation and one quarter rotation, so it will be 360 plus 90 degree. So this much angle it will subtend. Again, uh, let's say now this is adjacent angle, but this line is making now 90 degrees. So this angle will be 90 degrees again, because the sum of both the angles should be 180 degree. This particular case is called perpendicular lines. So let's say there is a straight line and there is a line intersecting it at 90 degree. So this angle will be 90 degrees, this angle will be 90 degrees, because again this is a straight line, and if this is 90 degree, this has to be 90 degree. So this will be 90 degree. So such lines are called perpendicular lines. Now let's study about the concept of transversal. What is transversal? So given two parallel lines, if a line intersects a two parallel line, this line will be called transversal. Let's say we call it a line T and line A and B, A B C D. So let us first understand what are parallel lines. Let's say there is a line A B. If I have to draw a parallel line to AB, I can either coincide with this, like let's say I'm drawing a line C and D, which is parallel, but essentially it becomes the same line, like A and B. So here in case like the angle subtended here is 0 degree between these two lines. But let's say if I take this line and it does not superimpose the line A and B or coincides with it. Let's say I draw a line parallel to AB, CD. So these two lines will never intersect each other, like it will never meet. If we extend it to infinity, like from left or right side, and these are never going to meet. So such lines are called parallel lines. And if there is an intersecting line which is intersecting both the parallel lines like this, so this is called transversal. There are many interesting properties related to like these sets of line. So there is a parallel line A, B, C, D, and a line here. So there are 8 angles formed here. What are those angles? 1, 2, 3, 4, 5, 6, 7, 8. So here, 3, 4, 5, 6 are called interior angles because they are lying inside this two parallel lines. So 3, 4, 5, 6 are interior angles, and 1 2 and 7 8 are exterior angles. 2 7 exterior angle. There are like different properties here, like which can be proved uh, or derived, you can say. Like there is a theorem like the corresponding angles are equal when a transversal is drawn to the two parallel lines. Like first of all, let's understand what are corresponding angles. So if we see if there are two parallel lines here, there is a transversal. Draw it. So let us draw two parallel lines here. A, B, C, D. So these angles 1 and this angle 2. These are corresponding angles. This angle 3 and this angle 4. These are corresponding angles. 3 and 4 are corresponding angles. 1 and 2 are corresponding. So this and this angles are corresponding. Let's say we call it 5, 6 and 7 and 8 are corresponding. So the axiom states like these corresponding angles are always equal. In this case, angle 1 will be equal to angle 2, angle 3 will be equal to angle 4, so on. So this is a axiom. Like again, we can see like this is very obviously. These are two parallel lines. The angle between this and this will be equal. So here, like corresponding angles will always involve one internal angle and one exterior angle. Interior and exterior angle. So here, let's say 5 is exterior, then 6 is internal. Again, let's see some other properties related to angles and straight line. Let's say there are two intersecting lines, A, B, C, and D. These are two intersecting lines. So these are called vertically opposite angles. Let's say X and Y are vertically opposite angles, and P and Q are vertically opposite angles. So it has very unique property. Like X will be equal to Y, angle X will be equal to Y, angle P will be equal to Q. We can reduce this or try to prove this as well. Uh, let's say let's say what we can say, like X plus P will be 180-degree, because this this is a CD straight line, and P and X are forming adjacent angles on straight lines. So like by the way, like these angles X plus P can be called supplementary angles. These special cases are called supplementary angles, where baseline is a straight line, and from there if a segment passes from the straight line, the adjacent angles sum is 180-degree. So these are called supplementary angles. And similarly, if we say P and Y will be P and Y will be 180 degrees. That means Y it will be 180 degrees. So A and B is a straight line, and again P and Y are supplementary angles. Cool. So can we say like these are two equal? So x plus P equal to P plus Y. P is cancelled out, means x equal to Y. So y is equal x is equal to y. Similarly, we can prove p is equal to q. So when two lines intersect, the vertically opposite angles are always equal. So again, let's see in case of transversal what happens. So let's say there are two lines again. There are angles 1, 2, 4, 7. In this case, we can say angle 1 equal to angle 4, angle 2 equal to angle 3, 5, 7. We can notice like angle 3 will be equal to angle 6. Is there any way to prove this? Okay, so we can take the help of axiom. Let's say angle 5 and angle 1 are equal. So in the same way, angle 6 and angle 2 will be equal. So like what we want to prove here. 1, 2, 6, 8. We want to prove 3 and 6 are equal. Angle 3 equal to angle 6. But from the axiom, like corresponding angles are equal, I can easily replace 1 with 5 and 2 with 6. So if we see this line, 1 can become 5 and 2 can become 6. This can become. So we want to prove 3 angle 3 is equal to angle 6. Now we know these are like vertically opposite angles. That means like 3 will be equal to 6, like we just saw above. We can prove in that way. So let's say we have proved 3 is equal to 6. So can we say 5 equal to 4? Because again these are like alternate opposite interior angle. So these are interior angles and these are opposite angles. So similarly, if 3 is equal to 6 and we want to prove 4 is equal to 5, we can prove it easily. Like angle 3 plus angle 4 is equal to 180 degree. Supplementary angles. Angle 5 plus angle 6 equal to 180 degree. And we proved angle 3 is equal to angle 6. So that means like these are equal. Angle 3 plus angle 4 equal to angle 5 plus angle 6. And 3 is equal to 6 will be cancelled. So angle 4 is equal to angle 5. So this can be proved. Yeah. We will see like how this different proof which we are deriving from axioms will build and like build to other complex proofs and theorems, proof solutions in subsequent lectures.